This will come as a joy to many of you. We're going to get back to proofs today. Still statements and reasons, but a new way to approach them. All right, I know that brings you so much joy. I can tell. Before we even touch any of these new types of proofs, I need you to be able to do something for it. And that is, you have 3 statements up there right now about triangle DEF. 3 statements, and I want you and your group to find 2 that contradict each other. Now, what do I mean by contradict? Meaning 2 of those at the same time cannot happen. Okay, it's mathematically impossible for these 2 to happen at the same time on triangle DEF. All right, so you have triangle DEF. I want you and your group to find this 2 statements at the same time. It's impossible to happen at the same time on triangle DEF. All right, so I'll let you guys talk. What do you think? Out of these 3 statements, if I apply 2 of them at the same time, no shot they can happen at the same time. All right, so go ahead and talk to your group. What do you think? You got to remember what scalene meant too, so you might want to talk about that. All right, so which 2, go ahead, cannot happen at the same time on that triangle?
Completely wrong.
Which 2 cannot happen? You can talk to each other about it. It's all right. Let's not just doodle on the paper, right? And somebody's going to give you the answer. Any group really confident because you talked about it, you understand it. Which 2 cannot happen at the same time? Just this group over here is confident. Which 2 cannot happen at the same time? All right, what do you got, guys?
It can't be scaly and have D and F.
What's it mean to be scalene first?
All the sides are different.
All the sides are different, but if I make D and F congruent, what type of triangle is that? Isosceles. Can't be isosceles and scalene at the same time. Okay? Cannot be isosceles and scalene at the same time. Correct. All right, so those 2 statements contradict each other because they cannot happen. And that's what's going to happen in your proofs today. All right, in your statements, you're going to have 2 statements written down that contradict each other. Can't happen at the same time. These types of proof I'm going to show you today and Monday. It's a 2-day topic. It's called indirect proofs. Indirect. If you forget any of the steps over the weekend, they're all right here. I'm not going to waste time reading them to you. We're going to hop right into the fire. So head to number 1, everyone. Head to number 1. Let's jump right in. All right, before we write anything down, I think we've done about probably in the ballpark of 70 to 80 proofs already this year. This is the first time we've ever seen this. Look at your proof statement. I have never asked you to prove this before. Something's not congruent. So if I ever ask you to prove in the future something's not happening, this is when it's time for this new type of proof called an indirect proof. All right? Anytime I ask you to prove something's not happening, we have to do a proof indirectly. Now, how do we do a proof indirectly? Well, step 1's nothing different, right? We write our givens in. Here's where it becomes different in step 2. And I guess we should probably mark it too, right? With our givens, AB equals BC. So make sure we mark that. AB, BC are equal. And I'm also telling you BD is not equal to BE. That's true as well. You can't really mark that, but remember that. BD is not equal to BE. All right, now here's where it becomes different. On your second step, we're going to do we're going to assume something is true. I could spell that. Assumption. We're going to put an assumption here. What are we always going to assume is true? Look at your proof statement. A not congruent to C. We assume the opposite of that is true. So A not congruent to C, the opposite would be angle A is congruent to angle C. We always assume the opposite of the proof statement is true. And go ahead, mark it on your diagram too. I know, where's he going with this? Give me time, give me time. So step number 2, we assume the opposite of the proof, always the proof statement is true. Good so far here. Grab your colored pencils, please. I'm going to hold your hand for this one. We're going to prove 2 triangles congruent here, or you're going to help me prove 2 triangles congruent. Triangle ABE. Triangle ABE with triangle BDC. I need your help getting those 2 triangles congruent. So triangle BAE, triangle BCD. I need your help getting those congruent. And we did a lot of this last unit, right? We had 5 methods. We got them highlighted. All right, you guys are going to help me now. Well, what do we already have? You're almost there. What do we already know so far? A side, right? A, B, and B, C, and A and C, a pair of angles. We already know those 2. So somebody in your groups right now, go back. What else do you see that you can tell me is true? I know those sides are equal and those angles. What else is true here? This is why I've had you highlight them as well. Take a look. Look at your paper. Something we've talked about before is true in your diagram. Look at them. Look at them. I need something in the triangles you have highlighted. Something else is true. I was hoping by highlighting them you would see this 3rd piece here. Any group see it? Confident? What do we got in the middle group here? Go ahead.
Angle DBE is congruent to
Everyone look at angle B. Isn't it in both triangles? Full angle in both. We got a little reflexive going on, don't we? Good, good. I know some of you are like, where is he going with this? Just hold on tight. Angle B congruent to itself. Reflexive. That gives me another pair of angles. All right, we have enough now to say my overlapping triangles are congruent. Just make sure we write it in the correct order. Triangle ABE is congruent to triangle. If I go ABE, I got to go CBD. I'll turn this back over to you guys. Need a method. Need a method from last unit. Why they're congruent. You have 2 angles and a side. Why are those triangles congruent? Need a method. Okay, here we go. Need a method. What's my method going to be here? Here we go, Henry.
Angle side angle.
Good deal, good deal. Angle, side, angle. All right, here's where the fun starts now. We proved the triangle's congruent. Didn't we learn something last unit that said, wait a second, if the triangles are congruent, any sides or angles that correspond are also congruent. Right? If the triangles are congruent, all their parts now are congruent. BD corresponds to what in the other triangle? Side BD corresponds to what in the other triangle? So I have side BD in triangle BDC. What does BD correspond with in my other triangle here, Bailey? BE, right? These two correspond with each other, so they should, because the triangles are equal, so are those two sides. What did we call that last unit? Yep, go ahead. CP, CTC. You are lucky right now that your paper is not catching on fire. I'm lucky right now that my board is not exploding. Do you see what you have written down in your statements? If you don't, look right now. Are you serious? Look at what you have written down in your statements. I even wrote it up here. Anybody see it? Go back to your givens. What did we say was true? BD is not equal to BE. And then what did you just write down? That ain't happening. That can't happen. You can't have they're not equal and then tell me they are. That's wrong. This is wrong because we said they weren't equal. I'm going to slow down now. This is wrong. Everyone agree? It's wrong because I told you they weren't. What led us here? What led us here? Okay, what led us here? This darn assumption. So what do I know about my assumption? It's wrong. So if my assumption is wrong, what's right? The opposite of it, which is A is not congruent to C. Let me do that again. Let me slow down even more. This is wrong because we were told that they're not equal. So if this is wrong, what led us here? What led us to this point? This assumption. So what can we say about the assumption then? It's wrong. So what's got to be right or true? The opposite of it, which is angle A not equal to angle C. And here's going to be our reason how we end every indirect proof going forward. Assumption, because that's what led us here. Assumption led to let's use a big boy, big girl word. What are those two right there? Contradiction. All right. Assumption led to a contradiction. So before we're not even ready for the second proof yet. Let's just go over everything we just did here because I told you, hey, prove these triangles congruent. How are you going to know that going forward to do that? First is, our assumption is opposite of the proof statement. Always, always. Somewhere in your statements, you are going to contradict one of the givens. Okay, you will always contradict one of the givens. And I'm going to tell you right now, the one you're always going to contradict, the not one. Okay, you will always contradict the not one in the statement somewhere. Okay, you will always contradict whatever the given is that's not happening. All right. Okay, let's see one more together, and I'm going to let you and your group do a third one on your own. Whoa. Before we start putting pen to paper so furiously, does everyone see why I need to do this indirectly? Look at the proof statement. What do you see in the proof statement? What do we all see in the proof statement? There's not a symbol, but I see the word not. Something's not happening, right? So that tells me time to do it indirectly. So the givens are already written. If they're not, you write them in. Now it's time for you to assume something. Remember where we get our assumption from? The same spot every time. I assume the opposite of it though. All right, so in this proof, what are we assuming here? What's our assumption in this proof? Dylan, what's our assumption in this one?
BD bisects AC.
There you go. So we're going to assume BD bisects AC. The opposite of the proof. Always look at your proof statement. The assumption's the opposite of it. Okay, last proof. Last proof, I told you where to go. I want your help now to tell me where to go. Somewhere, everyone's got everything written down. We can move on. somewhere in your statements, I want you to contradict one of the givens. And I always want you to contradict the not one. So look at your givens right now. You have two of them. ABC is not isosceles, and you have BD is an altitude. Which one do I want you to try to contradict? ABC is not isosceles. By somewhere in your statements, I don't know what step it's going to be, you should be writing down ABC. What's the contradiction of it? Is isosceles. So that's our goal right now as a class. I need your help getting triangle ABC to be isosceles. Because if you have that written down somewhere here, you got a contradiction. Right? So that's where I need your help right now. Show me ABC is isosceles. All right. You got a lot of you had BD as an altitude, and you have BD bisects AC as your assumption. Any of those can get you something that's true about my diagram now. We'll get to ABC's isosceles eventually, but not right now. What is true about my diagram? If BD is an altitude and BD bisects AC, there's a couple things you could tell me is true about this diagram, if you know what those vocabulary terms mean. You can either mark it or tell me to write it down here. Ready? Give me something that's true about the diagram then. Shoot, Drew, you're up.
BDC is a right angle.
BDC and what else?
BDA.
Good job. All right, so let's get that in my proof. Angle BDC and angle BDA are right angles. Now, usually, we'd write what? Perpendicular lines form right angles, definition of perpendicular. But I didn't have any perpendicular lines up here. Drew, how'd you know about the right angles? What word stuck out? Altitude. Yep, so now we'll write definition of altitude. Remember, they form right angles from this unit. We learned about that word this unit. What's been usually our process? When you tell me the right angles, what's usually the very next step? You tell me what about them? There you go. Same. That's not changing. Angle BDC congruent to angle BDA. Right angles are congruent. All right, good job. So we took care of the altitude part. We're still assuming AC is getting bisected, so what must be true now? Or anything else you think is true about the diagram? We know AC, side AC is getting bisected, or anything else you want to throw out to me. 2, 1, here we go, Lauren. Good job. Well, AD and, yep, good job. AD and DC. How did she know that? Well, Lauren knows her vocabulary. What'd you use, Lauren? Bisects. Definition of bisects. Good. Seems like we're just writing down some random facts, but we're not. It looks like you guys are pushing me towards doing what to these two triangles? You already have a right angle. You already have a pair of sides. What are we eventually probably going to do to those two triangles? Make them congruent. So then either these sides become congruent or these angles become congruent. And then what's the whole triangle? What type? And that's what I wanted. So does everyone see where we're going here? Prove the triangle's congruent so I can either get two sides or two angles to show its isosceles and get my contradiction. All right, I'm not there yet, though. I still need one more piece. Right? Still need one more piece. What do you got, Tess? Yep, got the old reflexive we can always count on. BD equal to itself. I haven't been doing a good job of putting A's and S's next to everything, but we're done as far as proving the triangle's congruent. I'm just going to need a method from somebody. So number 7, triangle. What do I go there? ABD. Congruent to triangle CBD. Just need a method from one of you. Method. Time. Henry?
Side angle side.
Yep. Thank you. Remember, you prove triangles congruent for a reason, to get some parts congruent. So what parts up here now would be parts I want congruent to say it's isosceles, right? There's a whole bunch of angles and sides I could say, but only a couple really matter that would make it isosceles. So what parts do you want me to put congruent to each other now? Ooh, 4 tests up again. Side, go say that again. A, B, N. That's fine. I could also go angle A and angle C. Either ones would make them isosceles. All right. So you guys, if you want the angles, put the angles. I'll go with Tessa's suggestion, which is AB, congruent to, what was it? BC. Ooh, still not done. How do I know they're congruent? Lexi, how do I know they're congruent? Yeah, there you go. Let it roll off the tongue. And yeah, this is your longest proof to date. Congratulations. Wait. If AB is congruent to BC, what type of triangle is it? Oh, be careful when you write this down. Spontaneous combustion. Triangle ABC is isosceles. And I'll accept definition of isosceles triangle. That's fine. Oh boy, that's awkward. I told you it wasn't in the givens, and now you're telling me that is. So what do we know about our assumption? It's wrong, false. So now once you have your contradiction written, once you have contradicted a given, we're done. The only thing left is that proof statement. Once you have contradicted a given, now we can say the proof statement's good. BD does not bisect AC. Ooh, 10 steps. Bisect AC. Assumption, and this is how all of them end. The assumption led to this contradiction. Always contradict a given. Assumption comes from the proof statement.